Hello viewers, welcome to TV Math. In our today's session, we shall be talking about question number 5 for Wakisha Mock, and it says that expand p plus x to the power of n in descending powers of p up to the first 4 terms. Hence or otherwise, find the value of 2.02 to the power of 10 to 5 significant figures. So let us look at the solution. Now, we are given p plus x to the power of n. If we are interested in descending powers of p, what we shall do is we shall first of all factorize out this p such that we can create 1 plus x divided by p. Because if it is x divided by p, whenever you are expanding this, you are decreasing the powers of p. So the whole of this one here is to the power of n. So this expression can be written as this. So from here, we can try to simplify this further to have this as p to the power of n into 1 plus x over p to the power of n. So this is the expression we are having, which we can easily expand using the binomial expansion. So if you recall very well from binomial expansion, it says that if you are having an expression of this form, 1 plus x to the power of n, this will be 1 plus nx, and then plus n into n minus 1 divided by 2 factorial x squared plus other terms. So if we have this, if we have p to the power of n into 1 plus x over p to the power of n, this one here, x over p, will be in position for this x. 1 is already there, then whatever we are having here will be representing the power. So if we try to put this one in this form, then we shall have p to the power of n into 1 plus x here. We are trying to relate it with this, and if we try to relate this, x over p is in position for x. So we shall have this as 1 plus n, our n remains, times x, our x is x upon p, then plus n into n minus 1 over 2 factorial, then x is squared. So our x for this case, we are considering x over p, and this will be squared. Then plus n into n minus 1 into n minus 2 divided by 3 factorial, and our x here will be x over p, which is to power 3. So that is the one that is in position for x. So that is the next term after this. So that is what we shall have. Remember, we are interested in the first 4 terms. The first 4 terms, this is 1, 2, 3, 4. So we shall be able to stop at this given term. Now we shall try to simplify this. 1 plus n p to the power of negative 1 of x, then plus n into n minus 1 over 2 factorial is 2. This one can be simplified as p to the power of negative 2, then x squared. Remember, this is x squared upon p squared. So you can write this as p to the power negative 2 x squared. Then plus n into n minus 1 into n minus 2 divided by 3 factorial is 6. Then this one will be able to give us p to power negative 3, then x to power 3. So that is what we shall have. So when we try to multiply p to the power of n into each of these terms here, we shall be able to remain with p to the power of n plus that is n. Let us try to look at what we are having. We are multiplying p to the power of n with p to the power of negative 1. So when you're having p to power n times p to power negative 1, this will be p to power n minus 1. The base is the same, so you add the power. So you will have that. So that is what we shall put there. So it means this will be n p to power n minus 1 of x plus n into n minus 1 divided by 2 p to power n minus 2 of x squared plus n into n minus 1 into n minus 2 divided by 6 p to power n minus 3 x to power 3. So this is the expansion of p plus x to the power of n. So that is what we shall get. So the question goes on and says, when you expand this in descending powers of p up to the first 4 terms, hence or otherwise find the value of 2.02 to the power of 10. So let us look at the hence part. We have already expanded p plus x to the power of n, and now we need to obtain the hence part. So these are our 4 terms, 1, 2, 3, 4, and you realize that the powers for p are decreasing. So this is the required expansion. Now let us look at the hence part. So for the hence part, we are interested in obtaining 2.02 to the power of 10. And if we are to deal with this in the hence part, we must make sure we try to relate what we need with what we already have. We have p plus x to the power of n, but we need 2.02 to the power of 10. So we can try to relate this with this one here. So when we try to relate this with this one here, we shall have this as 2. We can write this one here as 2 plus 0.02 to the power of 10. So when you try to compare, when you compare that expression with p plus x to the power of n, you will be able to relate your p to be, so you realize your p is in the position where 2 is, so we can relate our p to be 2, then our x to be 0.02, and our n to be 10. So when you compare these two, you realize that your p will be that, your x will be that, and your n will be this. So for that case, we can now obtain 2.02 to the power of 10. And 2.02 to the power of 10 will be, so we shall try to put this p, x, and n in this expansion here. So this will be equal to 2 to power n, n is 10, plus n, n is 10, times p, p is 2, to the power 10 minus 1, that is 9, times 0.02. We shall add there, n is 10, 10 times n minus 1, that is 9. We are dividing this by 2, then p is 2, then n minus 2, that is 10 minus 2, that is 8, and then x is 0.02 squared. Then plus n is 10 times this will be 9, this will be 8. We are dividing this by 6. P is 2, so we are multiplying by 2 to the power of 7. We are multiplying by 0.02 to the power of 3. So that is what we shall get when we try to put p as 2, x as 0.2, and n as 10. So we shall need to simplify this further. So this will be approximately equal to this one, 2 to the power of 10, that is 1024, plus when you try to simplify this, it will be able to give us 102.4, plus when you try to simplify this, you'll get 4.608, and when you simplify this, you will get 0.12288. So this will be approximately equal to 11131.13088. So this is the expression we are getting, but remember, we need our answer to how many decimal? Actually, we need our answer to 5 significant figures. So looking at what we have as 1131.13088, so we need to obtain this answer into 5 significant figures. So this is 1, 2, 3, 4, 5. So our final answer will be 1131.1. This is to 5 significant figures. So this will be the answer to 2.02 to the power of 10. Yeah.